Welcome to this explainer. Today, we are unpacking the massive technological shifts outlined in the McKinsey 2025 Technology Trends Outlook. And listen, the global tech landscape right now is transforming at a breakneck pace, driven by a force they call combinatorial innovation. Honestly, that's just a fancy way of saying we aren't looking at isolated breakthroughs anymore. Technologies are literally crashing into one another, creating entirely new ways of working and living. So we're going to explore the massive surge in computing, the race for strategic leadership, and real-world applications that are moving straight from the lab right to your desk. Let's dive right in with a frankly staggering number, 985%. That is the explosion in job postings for Agentic AI from 2023 to 2024. I'm hitting you with this right out of the gate because it instantly establishes the massive stakes of this year's trends. This is not some slow, gradual evolution. It's an overnight pivot. Companies are aggressively hunting for the talent to build systems that don't just talk, but actually do. At the very center of all this is artificial intelligence. In the McKinsey report, AI stands out not just as its own wave, but as a foundational amplifier that connects all 13 trends they analyzed. It's the catalyst that is rapidly dissolving the boundaries between physical and digital realities. Whether it's training robots, advancing bioengineering, or optimizing our power grids, AI is the absolute engine driving this unified tech revolution. To make sense of this massive report, we've organized our explainer into 4 interconnected chapters, plus a strategic summary. We're going to cover 1. Agentic AI 2. Humanoid robotics 3. Quantum and next-gen silicon 4. Sustainable energy and 5. A strategic outlook. All right, let's jump straight into Chapter 1, Agentic AI. This first macro trend is all about shifting us from conversational assistants to fully autonomous digital brains. Simply put, Agentic AI is an artificial intelligence system capable of independently planning and executing complex, multi-step tasks. So what sets this apart from the AI we've gotten used to playing around with? Well, it's all about action. We are moving away from mere text generation to actual virtual coworkers that autonomously use digital tools, browse the web, and communicate with other systems to actually get things done. We're shifting from traditional, passive, conversational chatbots toward active AI collaborators capable of long chains of effective, multi-step reasoning. Instead of relying on one massive, clunky model to do everything, developers are now deploying multi-agent workflows. Imagine a manager agent that receives your prompt, breaks it down into a comprehensive work plan, and then delegates specific tasks to highly specialized sub-agents. It's a fundamental rethinking of how AI systems operate. Let's ground the hype with some concrete 2025 examples. First up, there's OpenAI's Operator, which is an agent that can autonomously navigate websites, fill out forms, and handle tasks like booking flights. Then, we have Manas AI, which acts as a flexible digital teammate for research and task management. And in cybersecurity, Darktrace is using autonomous agents as a sort of cyber immune system. They continuously monitor networks, identify anomalies, and mitigate threats in real time, completely without human intervention. How wild is that? This shift from a passive tool to an active collaborator is absolutely profound. It demands a total rethinking of how we interact with tech. Think about your own daily workflow for a second. We are moving past traditional coding into task planning and tool orchestration. This means we desperately need new skills like prompt engineering, and crucially, we need incredibly robust governance frameworks to ensure transparency and accountability when these agents are operating on our behalf. Moving seamlessly from the digital brain, let's look at Chapter 2, Humanoid Robotics. We're taking that digital brain and putting it into a physical body. The explosive future of autonomous machines is moving way beyond the traditional factory floor. We're talking about robots capable of performing tasks autonomously while adapting to unpredictable, real-life inputs. What's so fascinating is the crossover here. The exact same foundation models that power our chatbots are now being adapted into vision-language action models. This allows robots to understand their environment, reason through complex tasks, and execute fluid movements in spaces built specifically for humans. Looking at the 2025 breakthroughs, the progress is undeniable. Figure AI introduced Helix, a model that allows humanoid robots to dynamically recognize objects, like putting away groceries, without needing any prior rigid training. Boston Dynamics unveiled their fully electric Atlas, boasting seriously enhanced strength, which Hyundai actually plans to deploy in automotive manufacturing. And of course, Tesla's Optimus continues to be refined for general-purpose tasks in both industrial and domestic settings. The market opportunity here is massive, projected at up to $900 billion by 2040. Robotics is officially a top-tier CEO agenda item. But let's be real. mass adoption isn't happening tomorrow. We still have to solve some massive constraints. For instance, a state-of-the-art untethered humanoid right now only operates for about 4 hours before needing a 2-hour recharge. We also have to solve tricky physical challenges like balancing on 2 feet, all while addressing workforce reskilling and the psychological shift of humans working side by side with autonomous machines. That brings us to Chapter 3, Quantum and Next-Gen Silicon. Because here's the thing, you absolutely cannot have brilliant digital brains or agile robotic bodies without the immense hardware foundations required to power them. We are looking at the foundational architecture of the AI revolution. General-purpose computing architectures like your traditional CPUs simply cannot keep up with the exponential demand for parallel processing and AI inference. This bottleneck has ignited a completely new, hyper-competitive hardware race. And this brings us to application-specific semiconductors, which are chips tailored and optimized for exact workloads. What's really incredible to watch is how this demand has completely fractured the traditional supply chain. Tech giants like Amazon, Google, Meta, and Microsoft aren't just buying off-the-shelf chips anymore. No, they are bypassing traditional suppliers entirely to design and build their own custom AI accelerators perfectly tuned to their proprietary models and data centers. But classical silicon is really just half the story here. The quantum race has seen massive leaps in 2025 as hyperscalers conquer long-standing error correction hurdles. Google's Willow chip recently performed a benchmark computation in 5 minutes that would take a supercomputer 10 septillion years. Think about that scale. AWS's Ocelot uses cat qubit technology that could cut error correction hardware costs by 90%. And Microsoft's Majorana 1 is pushing forward with topological qubits for incredible stability. We are officially shifting from theoretical physics into industrial-scale engineering. We have to connect the dots here, though. This massive leap in computing power generates an incredible amount of heat and demands unimaginable amounts of electricity. The physical constraints of our global infrastructure are rapidly becoming the primary bottleneck to the entire AI revolution, which leads us directly into our 4th core trend. Chapter 4, Sustainable Energy. We have to figure out how to power this revolution without completely breaking the global energy grid. The crucial point is this staggering figure, $223.2 billion in equity investment in energy and sustainability technologies in 2024 alone. This proves sustainability is no longer just a regulatory checkbox. It's a necessity. Clean energy, electrification, and grid modernization are foundational to sustaining the AI boom. Simply put, without clean electrons, the compute revolution stops dead in its tracks. Data centers alone are pushing electricity demand to its absolute limit, exposing deep cracks in our current infrastructure. This trend is all about the urgent innovations transforming the energy value chain to meet this historic demand. We desperately need to deploy low-emission power systems, manage the intermittent nature of renewables, and massively overhaul our grid governance and infrastructure to handle the load. But the solutions are just as high-tech as the problems they solve. We're seeing rapid integration of advanced cooling systems for data centers and smart grid technologies where AI itself is being used to optimize our fragmented energy systems. Plus, advanced measurement tools like satellite imagery and LiDAR are tracking land use and emissions with unprecedented precision. This ensures we're actually hitting our sustainability targets, not just guessing. Okay, let's wrap this up with Chapter 5, Strategic Outlook. So how does all of this build into an actionable game plan for decision makers in 2025? The McKinsey report distills the noise into 3 clear directives. First, leaders must identify high-impact domains where these trends, like AI and robotics, intersect to create real value. Second, there has to be a dual investment in physical infrastructure and human talent to bridge the massive skills gap. And third, organizations have to address regulatory gaps and prioritize ethical innovation. Trust is the ultimate gatekeeper to adoption right now. You have to balance massive centralized scale in the cloud with localized, adaptable control at the edge. We want to leave you with this final, provocative thought. The lines between the physical and the digital, the passive tool and the active collaborator, have permanently blurred. As agentic AI becomes your literal coworker, as humanoid robots enter your facilities, and as data centers demand a revolutionized energy grid, is your infrastructure, your strategy, and your workforce truly ready for 2025? It is a combinatorial future, and the time to build for it is right now. Thank you so much for joining us for this explainer. Keep learning, keep questioning, and we'll see you next time.